Hello, everybody. We are Vasilis Aloutsanidis and Ines Champagne. We represent Volted. Most of you might know Volted is a spin-off of ETH, came out from BRG, Blog Research Group, and it's founded back in 2023. I'm not gonna go through the introduction of Volted. We're gonna go directly to the subject. So last year we presented our workflow in Volted, how we try to bridge the gap in between Volted, as you see it in the left, with all the collaborators and partners in the industry. And this is a worked out pipeline going through the input we get from the requirements of the building, form finding, creating the base geometry, and then from then on we can decide what detailed geometry we want to produce for different purposes. For example, for structural analysis, for fabrication data, or for building implementation. And of course, the goal of all of this is the proper communication between us and the collaborators, and of course, the construction of the projects. This is what was said last year. This year, we have made a step forward, and we identified for each step. Here you see an example for the fabrication workflow. We have identified which parameters or inputs we need for each discrete step. And this created, or we worked on several packages that are called, let's say, Volted packages, to mitigate all these workflows, to include all these workflows. And of course, all these packages are based on COMPAS packages. I will explain a bit later how exactly this works. Of course, at the same time, parallel to the fabrication workflow, as you saw and we discussed last year, we have the structural analysis and the building integration. For structural analysis, you see that we're using COMPAS FEA, on which Ines will expand a bit later. And building integration, we created a new package called Volted Building. I will go through the packages a little bit to explain the content and what each package is doing. So to control all these different packages, we created Volted Core. You're probably familiar with Session. So in here, we're using COMPAS Session, which is already a setup, let's say, tool in COMPAS, and COMPAS Viewer for the visualization. Then in the Volted buildings, we are using this library for the building integration, the IFC management, and the design of the structural elements, or the integration of the structural elements in our pipeline. Volted Floors is focusing on the design of the floor itself, the ribbon floor system, using, of course, DNA, volumetric design. Volted Formwork is focusing on the generation of the formwork after the floor is generated. So we use here a COMPAS model in order to control all the different components and go into detail, both for the design, but also the coordination with the prefabricators. Volted scaffolding is focused on the on-site and the transportation tools. And of course, in the end, there is Volted Cost, which is using the models in order to know how much the project is going to cost in total. Of course, all these, as I said before, all these packages integrated in Vaulted are using in the background COMPAS. For example, COMPAS Core is using COMPAS Session and Viewer. Vaulted Core. Vaulted Building is using COMPAS Model and COMPAS IFC. Vaulted Floors is using COMPAS Model and COMPAS TNA, and then COMPAS Model for the rest of the packages. Focusing now on the COMPAS FEA part I explained before, Ines will say more about it.
Hello, I'm Ines. I'm a structural engineer in Vaulted, and I'm working on the COMPAS FEA 2 library, which is focused on finite element analysis. Just a reminder of what is finite element analysis. So it's when I want to study structurally an object, but the problem is that object in reality is composed of an infinite number of points. So to make it easier, I discretize this object in nodes that are linked with elements. So I can make possible the study, then I study the thing and I can get my results for structural assessment. To do that, I have several software that can do finite element analysis, such as Abacus, Sophistic, or OpenSys. The thing with this software is that they have each their own language and specificities, and to learn them all can be complicated, like can be quite a nightmare. So to make it easier, we are doing COMPAS FEA 2. So it's a unique, a general API for finite element analysis. So we create a unique language to be able to run analysis in one of the software. So I could do with the same language, the same script, the analysis for the same problem with Abacus or NZIS or Sophistic as I wished to choose. So this is the objective behind COMPAS FEA 2. It has a specific structure to build a problem. So first we have the input, which is like the geometry, which is perhaps complex or not. And we can use external libraries from COMPAS to import this geometry. Then we implement it in COMPAS FEA 2. We create the model, which is all the mechanical properties like behavior, what material, and also the boundary conditions. What is the relation of my object with the environment? Then the problem, what I want to study on that object, like what is the loading, what kind of analysis I want to see. So this is where I define that. And then I run the analysis in the backend software I chose from the software I showed you before. And then I get the results. What is interesting that we implemented in COMPAS FEA 2 is that we have a unique database in COMPAS FEA 2 that stores in the same way the results, whatever software you used at the beginning, which is often a nightmare too. So it's this unique database that could be shared, for example, to a client. Then it could like open this database and shows the any viewer he would like to use to see the results. So now let's see the structure on the script. So we will see that quickly on that thing, and then we will see a more practical example. So the first part is the model. So in the model is made of several parts. In each part, I define what is the behavior. So the material, the sections, then the geometry. So as I said, what are the nodes and the elements, how I discretize my object. And in the end, what is the boundary conditions, how it behaves with its environment. Then this is defined. Then I apply my problem. So my problem, it's a specific kind of analysis. Is it a heat analysis, the impact of temperature, or is it a structural static one? Well, so it's more about loading. I define the loads. Then I say, what do I want to know from that model? So is it the results I want? And then I do the analysis to get the results. So let's see all of that on a quite simple, let's say, example, which is a point load on a plate. So first, I did the input phase, which is with here COMPAS geometry and COMPAS gmesh. I created a geometry and a mesh. We can see it on the right. And then I've took this geometry and I put it easily on COMPAS FEA2 to get my geometry. Then I define all the material, the boundary conditions to my model. And then I figure out what is my problem. So there is just like a punctual load that is applied on my model mesh. And you can see also that thanks to my script, I detailed my mesh to be more detailed around the punctual load. So I have better results. Then I do the analysis and then I get the results. So here I'm just showing the deformation and the displacement. So I can see that indeed, where I applied my load, as you would expect, my plate has some deflection. So there, for the visualization, as you can see, we can use several plugins, such as COMPAS Viewer or COMPAS FEA2 Vido, which is Vido, a specific plugin from Python to see results that we implemented. So this is, like, in a few words, what is COMPAS FEA2. What's next? Because we are not yet finished, but almost. So for all
Ja.
the core COMPAS FEA2.
Ja, hörst du mich? Okay.
Okay. So for
Ja,
the
ich als andere jetzt eben,
to the
als
backends, we are
anderen eben
quite
da.
finished.
Oh,
We
Scheiße,
need
warte
to
schnell.
work still on the documentation to make it more understandable. Example and tutorials, still a lot of work. And it's more on the user interface to implement some plugins for the visualization, such as COMPAS Viewer or COMPAS Vido that we need to work. And we would accept any help to develop these viewer plugins. Well, thank you for listening. And if you have any question, you can ask now or later. Later.